Right on. Hopefully you guys got all that written down. I'm gonna move on. We're gonna start. We're gonna start defining some of these things. Okay, y'all know a lot of this stuff already. I think the coordinate. Anytime I talk about a coordinate, that just means the location of the point, right? The location of the point. We already know what a point is. A point is represented by a what? A dot. Okay, points represented by a dot. That was lesson 1, right? Okay. So now we're like, hey, you got a coordinate. A lot of times you'll see this in what we call a Cartesian plane, the good old XY axis, right? I keep getting, we'll go over this over and over, but pretty soon you're going to have to learn it, commit it to memory. It goes XY. X moves left to right. Y moves up and down. In later math, they'll tell you that I was an idiot for teaching it to you that way, but all of you are going to learn it left to right, up to down. Okay? So if I give you a coordinate point of -3, 5, okay, that tells me if the first number is negative, I move to the left 3. Right? To the left 3, 1, 2, 3. The second number is positive, tells me I would go up 1, 2, 3, 4, 5. Right? I'm gonna work somewhere in that quadrant. Okay? Quick rehash of the quadrants. Start in the upper right-hand quadrant. 1, 2, 3, and 4. Okay? They go counterclockwise. Going from the upper right, right? Now that is like 3 weeks of coordinate algebra into a minute. Pretty good. Congruent means identical. This is my first promise to you. First promise to you. You will not get through this class if you don't know what congruent means. First promise, I promise. You will not make it through this class if you don't know what congruent means. Now, some people take that negatively and they're like, oh my God, I'm done. It's not a very hard definition, right? It means identical, the same, the exact same, okay? So let's talk about an example of congruency. Okay. There's one circle, 2 circles, 3 circles. If each of the radius of these circles was 5, those circles would all be congruent. They have identical measures. Okay? Got me? Identical. I know they don't look the same. Look like Pac-Man. Okay, good. All right. So we're going to do our first test of the year. I'm going to say, what is congruent? And you say identical. What is congruent? Identical. Perfect. We don't need to do it again. Okay. We'll be doing congruent later today. Okay. Matter of fact, you'll get so sick of the word congruent that you'll be like, don't talk to me. Construction. Okay. Construction is this is being recorded, so I'll admit it. Not something we do too much. I think really great geometry teachers would probably have you do it all the time. Maybe later in life, you're good to get one of those. All right, just kidding. We do some construction in here. The problem that I have as far as this class is concerned is on the EOC, you don't do anything hands-on. You don't do any hands-on, they don't ask you on the EOC, take the scissors and cut me out congruent circles. That's not what they do. So that's not what I do, okay? There's fun ways to do the geometry stuff, but what they're going to ask you on the EOC is stuff like, hey, look at this drawing and tell me what's the next step to get an angle bisector. We don't know any of that right now, but pretty soon we're going to talk about, okay, this is how I would construct an angle bisector using a compass and a straight edge, all right? So we actually have, we don't hands-on do it as much as we just learn the process of getting it done. Okay? Talk about constructions down the road. All right, here we go. Now we got the good stuff coming our way. Midpoint bisect and segment bisector. Woo! The midpoint of a segment, when it says segment, it's the line segment. Okay? The midpoint of a segment is the point that bisects or divides the segment into two congruent segments. All right? So there's a reason we talked about congruency first. What does congruent mean? Same or identical, right? All right, guys. Here we go. I'll make this very easy to begin with. I started with 0. And I get to 10. The midpoint of 0 and 10 is what? 5. How did you do that? Okay, common sense. Well, there's a little math behind your common sense. If you aren't, my niece is 3, and if I said, Lane, tell me what the halfway point between 0 and 10 is, she would not say 5. She said, oh, you're silly. What did you do to get 5? Divided by 2, right? Got me? Okay. So you got 5 right here, okay, which is good, right? And if I think about this not in terms of numbers, but instead in terms of units, how many units are there between 0 and 5? No. Here we go. 1, 2, 3, 4, 5. There are 5 units, correct? 5 units. How many units are there between 5 and 10? 6, 7, 8, 9, 10. Correct? 5 units. Right? Holy smokes. What do I have? 5 units on one side, 5 units on the other. Smells like a identical segment to me. Correct? I've got 2 identical segments on either side of my big segment right there, okay? All right, so we got a lot of stuff in there. Okay, here we go. Midpoint is 5, right? Take the total number of units divided by 2. It's as simple as I can do for midpoint, okay? There will be other ways that we learn distance formula, midpoint formula, and all good stuff we'll talk about later. But right now, check it out. Take the total units divided by 2. Okay? The point in the middle is called the bisector. So this represents my segment bisector. Okay? That 5 right there represents my segment bisector. The segment connecting the midpoint is called the segment bisector. In other words, remember we had segments earlier in the class. We talked about this. If I labeled this AB, I labeled this CD. I kept the 5 units up there, and I said that point right there, E is the midpoint. That means that that point, that CED point, is my segment bisector. Right? Any questions on that? Okay. Getting a couple of stairs out there that I'm not sure about, so maybe we'll use some other examples and see how well we do with it. Okay. I'm gonna move on. You ready? Definition. Okay, you got 5 seconds. Isn't that? Okay. CED represents my segment bisector. Okay. If I say that point E is my midpoint, that means that that line segment right there, CED, would be my segment bisector. You good now? Okay. All right, guys. Degrees. Okay. Today I said we'd be working on line segments and angle measurements. Angles are measured in degrees, right? Let me do a quick recap of an angle. My definition I want you to remember of an angle. An angle is when a line segment, or array intersects with another line, segment, or array. Line segment, or array intersects, remember, crosses with another line segment, array. How do we measure angles? We measure them in degrees. The measure of an angle, usually given in degrees. This is where your first geometry intuition comes in. There are 360 degrees in a circle. So 1 degree represents 1 over 360 degrees of that circle. Okay? 1 over 360. Again, something that's hard to define and easier to understand conceptually when we start getting into examples. Right? How we doing? Okay? Okay so far? Okay. All right. You don't have to write this down. Okay? I'm going to show you what it is. I said when a line segment, or array, we'll make this one array, meets another line segment array, we form an angle. Let's use our proverbial ABC. See, using that line, right? So we said, hey, we can name this angle ABC, CBA, or we can make it really easy and say that's angle 1, right? Remember that from yesterday? Correct? Okay. Then I'm going to say, hey, what is the measure of angle 1? Okay. And again, we could use a construction. We could get out our protractors and literally measure the angles. Or I could tell you this angle is 47 degrees. Okay. So I promise, y'all probably already knew that. Harder to define, easier to understand. Okay. Here we go. First big one. I want you guys to work out this problem too. So, of all the notes we've taken all year, here's the ones where you need to make sure you write it down. These are the examples that we'll do throughout the year. Okay? You do not have to write this part down. Okay? If you don't want to define the segment addition postulate, you don't have to, but I do want you to take a look at it. I'll talk it over. If B is between A and C, then the measure of A to B plus the measure of B to C equals the measure of A to C. Some of you out there are going, well, no duh, right? Some of you are looking at it like, what did you just say? Right? Some of you may be in between. Take a real world example. Real world example. We're in what city? Tallapoosa. Town. Tallapoosa, right? Correct? Let's just pretend there was a direct path. Tallapoosa, there is a direct path, actually. We go from Tallapoosa to Douglasville to Atlanta, right? Tallapoosa to Douglasville to Atlanta on 78. Go with me? If I wanted to know how far it was from Tallapoosa to Atlanta, I could take the measure, the miles, from Tallapoosa to Douglasville, and add them with the miles from Douglasville to Atlanta. Correct? Okay, you got me? Some people aren't math people, so we have these drawings and stuff. But that's a real world example right there. All right, let's look at this word problem. First tip of the year. I made you a promise earlier. Here's the first tip. Okay. Anytime you get a word problem, you need to draw a picture. Word problems tell you to draw a picture. So, G is between F and H right now. F, G, H. Did I just do what the problem told me to do? G between F and H. Doesn't have to be a great picture, just draw one. Okay? F to G is 6. So here we go. Let's make our line because we're talking about segments. F to G is 6. F to H is 11. So The whole thing is 11. How much is G to H? Real simple, right? And if I asked you what's the math behind that, what would you tell me? Okay. They would probably fire me if I didn't show you this. So, hey, it's math. You got to put an X there and find it, right? You could just say 11 minus 6, but 6 plus X is 11. Subtract 6 from both sides. Voila. X is 5. And then, if I got algebra, I'd tell you, oh, you have to plug your solution for X back into the equation and check the work. But I don't teach algebra, so I don't really do it. Okay? I'll let Ms. Gray and Gober and Mr. Young and everybody else know that. I'll do this. Okay? You'll know if it's wrong. If you get -5, you're wrong. Okay? You're not going to get any negatives in this class. Okay? Because you're not going to have a negative distance, are you? Right? That wouldn't make sense. Okay? If I told you, hey, it's -20 miles from here to Douglasville, you'd be like, no, it's not. And you're right, it's not. Okay? So it's not going to work out that way. No measurements in here are ever going to be negative. Yay! No angles are ever going to be negative. Yay! You don't have to worry about negative numbers. Everybody get that written down? You good? Okay? Ooh, here's a hard one. You guys try this one on your own. Okay? 3 minutes. Try that one on your own. Okay? The postulate's the same. Okay? It obviously, I probably should have written the directions up here. I want you to find X. Find or solve for X. Okay. Think about how you could set it up, just like our warm-up. Okay, there's a hint. Just like our warm-up. Where to get it? See some good stuff. I'll help you out. Here's kind of how I do it. Okay, it's about a minute to think through the problem, right? If you got this far on your own, that's great. If not, let me show you how I'd set this up if I were in your shoes. N to M is 17 plus M to 0, 3x minus 5, has to equal the entire distance from N to O, which is 5x plus 2. All right? So hopefully you got that far on your own. If not, correct your work. That's how you should set it up. And then from there, you play everybody's favorite math game, solve for X. Okay? But it's easy algebra, right? Still, it's pretty easy algebra, right? Not even a fraction involved. You don't have to factor anything. No quadratic. See how everybody does here. I'm going to start it off and lie to you. Because I said the first thing I would do would be what? Add things to both sides, right? Why did I start off by doing that right there? Very good. Okay. I'm essentially going to get this part by itself first before I'm going to do anything else. Here's going to cancel out 17 plus -5. Now I'll write that 2x plus 2. Y'all with me? Okay. 17 plus -5. That's the same thing as 17 minus 5. Okay. 17 plus -5 is the same thing as 17 minus 5. 12. 12 equals 2x plus 2. Subtract 2 from both sides. 10 equals 2x. Divide both sides by 2. What do you get? Hopefully everybody got that. X equals 5. Okay? Really everybody 5. All right, check your work real quickly. Make sure you're close to what that is. Let's see here. 20 minutes. I'm going to be done in 4 minutes. Promise. Okay, we got 4 minutes left. I'm good with that? Okay. We're going to skip over that one. Although, actually, we're not. I'm going to do this one with you, okay? Read the directions carefully. It says, D is the midpoint of EF. E to D is 4x plus 6. D to F is 7x minus 9. Now, there's a really key. It wants me to find E to D, D to F, and E to F, okay? I'm actually not going to do that. I'm just going to show you how to set up this problem. Okay? The key definition in there, key word, this whole problem, you got to know what a midpoint is. A midpoint serves as a bisector, right? It bisects a segment. It also bisects a, well, for now, let's just say that, bisects a segment into two congruent, meaning what? Equal segments. So if I just do this, 4x plus 6 equals 7x minus 9, I could solve for x, plug my numbers in, and I'd have my answer, right? You got me? Okay? But if you don't know the definition of midpoint, you're going to be a lost puppy on that one, right? So remember, midpoint splits a segment into two congruent segments. From there, you just got to use your noggin a little bit and say, all right, if this E to D is congruent, D to F, that means they have to be equal. Equal, because congruent means identical. Identical in math language means equals. Okay? Let's see. Say that again. You would need more information. Simple answer. Okay? 5 again, right? Y'all get 5? I gotta keep my promises, so we've got 2 minutes left. All right. Ooh, angles. Yeah. Same way that we just did line segments. Okay? Your angle addition postulate. Check it out. It says S. Let's see here. Is Q to S array? Q to P array? Q to R array? All right, good deal. All right. The big angle, it says, is angle PQR. Okay, that means that PQS, which they have highlighted as red, that angle, right, plus SQR, blue angle, equals the larger angle itself, right? Okay. In their example, it says the big angle DEG, the entire angle. So watch how I do this. The whole angle is 115 degrees. 115. Right? DEG is 115. DEF is 48. All right. Very simple, right? How could I find the measure of FEG? Subtract it, right? They, again, would want us to say, okay, this is X. How do we find X? Well, you simply subtract 48 from 115. And 57. Now I got to add them back together. Okay, 57. Now let me embarrass that. I did too. That's okay, we're getting that board out. You what? I was just testing you. You know, we don't have calculators out here yet, right? But you're cheating here on your money. All right? Just kidding. Okay. All right, any questions on that? That's pretty easy, isn't it? That's actually the hardest example I can give you. And as promised, we're done.